Right. See, now today we are going to learn about image formation by concave lens. See, when object is at infinity, what will happen? The light rays will come like this, and they will appear to come from F. So here the image is formed. At F, you can write position of image. So what you will do? You will write like this. Position of image means you will write at F. Okay, at F. And what is the nature of the image? See, the light rays are appear to come from. So you have to say it as virtual and erect. Okay, nature of image, right? Nature of image, virtual and erect. Virtual and erect. Okay, virtual. Okay, and what is the size of image? Size of image, the image will be formed. Okay, the image will be very highly diminished or point sized. You can say highly diminished or point sized. You can write. Okay, point size. Now next one is when the object is next case number 2. When object is at any other point other than infinity. Other than infinity. So when the object is at any other point other than infinity, that time you can take like this. What the concave lens you can take like this. For example, in this case you no need to mention where the position of the object is. Somewhere the object might be there. Okay, so the light ray which is going like this will go like this from optic center. Of course, a little thicker we'll try to do a little. Why? Because it is very thin, it is appearing. So lens. Okay, we'll make a little thicker lens and show it a little clearly. Okay, like this. For example, this is the optic center 4. So it will go like this, and the light ray which is going like this. Okay, it will go like this. These, for a person who is seen from this side, for that person, these light rays will appear to come from here. So what we'll do, we'll draw the image here like this. Okay, what you do here, you draw like this. Okay, so this is A dash, B dash. See, generally in the both the cases, here object we are not mentioning, and here image also A, B, A dash, B dash you are not mentioning, because it is somewhere at infinity. So dot 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 somewhere here there might be A, B object like this. Okay, and here very points as so A dash and B dash will merge only. That is the reason we don't show. Okay, now here what is the nature of the image? Simply you can write the nature of the image, position of image, and position of image. What you have to do? You have to say it is formed on the same side of the object. You have to say. Okay. 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 The image is formed on the same side of object. Okay. Same side of object. Object. Okay. And this nature what will happen? Nature of image will be virtual and erect. Virtual and erect. And the image will be diminished. Means size of the image will be diminished. So this if you write is enough. And anyhow, see this convex and concave mirrors, some uses you can say for example, convex mirror is used in a magnifying glass. We can see small objects bigger, and in projectors we will use it. Okay, in spotlights etc. Convex lenses we will use it. Like that you can write many uses. Simply I will write some points. Uses of convex means simply you can write as a magnifying lens. Okay, in projectors, it is used in projectors, it is used in spotlights. Okay, spotlights. Okay, okay, and more you can say it is used in what you call in defects of vision. As far as I know, it is hypermetropia to cover. Okay, hypermetropia. Okay, so it is used like that. Okay, so this is about uses of what? A convex lens. Convex lens. For example, if anybody is asking what is the use of concave lens, means you can say it is used to correct the defect of vision, that is myopia you can say. Okay, and also see generally these concave lenses etc. are used in telescopes. So you can write the use as telescopes etc. So this like that you can write enough. Now we will go to the next sign convention. See, sign convention what you have learned in the mirrors, here also it is same. Only thing is in mirrors we will say generally P, pole, the center of the mirror is pole, and here we will say optic center. And some differences are there like that. And in the formula anyhow, mirror formula and what do you call lens formula not the same, right? So in lens formula you will get 1 by v minus 1 by u is equal to 1 by f. So this is lens formula. Okay, so sign convention anyhow once I will say orally so that you can go through. Okay, first point, what all the distances are measured from the optic center. First point, that is about first point. Sign convention for what? For lens. For lens, all the distances are measured from all distances are measured from, okay, are measured from optic center. That is nothing but O. And second one, the distances measured in the direction of light ray are taken positive and opposite we will take negative. So distances measured in the opposite direction of light ray like that, you can take it as negative, and the distances measured in the same direction of light ray you will take positive. Okay, so okay, distances measured is all you can write. Okay, and generally if you are taking object on the axis like this, for example, you are taking a convex lens like this. Generally you are taking object above the axis. So distances taken above the axis means the heights of the object etc. is taken generally positive. So this you can say like distances measured above the principal axis. Distances measured above principal axis are positive. Positive, and below principal axis negative. Below negative. And generally, so these are the things. Now what we will do, if you take the formula, first of all we will take lens formula. What is lens formula? Is 1 by v minus 1 by u is equal to 1 by f. Okay. So now magnification formula will be v m is equal to v by u is equal to height of image by height of object. So this you have to take. Now some see these are all sentences I said orally, but I didn't write. You can see all distances are measured from optic center, or measured from optic center like that you can take. So I said orally, so those you can write. Now next one, if ME is numerically you take, for example, this is these are formula of course. Fourth point in sign convention like that you can take like this, otherwise 1 2 3 of course you can write otherwise separately. What are the 3 points I am going to say is, if M is less than 1 means numerically, I said you numerically you have to take these values. Okay, if you take minus 1.5 and plus 1.5 also, what I said, both will be considered as above 1 only, but M is plus minus means that will appear for nature of the image. So that means if see for nature of image I will say there are 2 more points. For example, you are taking nature of image, that time if M is negative then the image will be real inverted. Real inverted. If M is positive then that time the image will be formed is virtual and erect. Okay, so this for positive negative in this case it will appear. But in the case of magnification, that is nothing but enlarged, you would say if M is less than 1 it is diminished. If M is equal to 1 you would say it as small size, same size, and if M is more than 1 you would say it as enlarged. So these are the things. Now what we will do, this is sign convention, we will do some numericals on the this convex and concave lenses. See, randomly you can take some values. For example, say the focal length of the, we'll create a question and do. See, for example, the focal length of the convex lens is 20 centimeters. If the object is kept at 30 centimeters, where is the image formed and what is the nature of the image? For example, that is a question. Okay, so a question will be given like this. Okay, an object is placed at 30 centimeters. Okay, and the focal length is 20 centimeters. Focal length of the convex mirror is convex lens is 20 centimeters. Find the position of image. Find the position of image. Nature and size of image they say. For example, position of image, nature and size of image. nature and size of image is asked. So what you have to do? Simply you have to take like this. First of all, you have to take like this. What solution? You write like this. Given points you write. What is so object distance? You can write in words. Okay. Object distance. So you can take it as minus 30. Focal length for convex is positive. You have to take. So object distance symbol is U. Okay. So positive for convex lens, focal length, and formula you take. Okay, and substitute the value. What will happen? You will get like this. 1 by U means minus of minus 30. It will become 20. So this will become plus. So here minus of minus will become plus. So now if you take 30 that side, you will get like this. Now you make common denominator, for example. Now what you will do? 1 by V means common denominator is 60. So it means that 20 into 3, 20 into 3. So here you will get 3 and here you will get 2. So you will get 1 by 60. Okay. So therefore V is at 60. You can write. And what is the nature of image means? You have to take the formula. M is equal to V by U. Na? So 60 by minus U is how much? Minus 30. So you got a minus 2. So it means that the image formed is real inverted. What is it? Image formed is real and inverted. Okay. So this is image formed is real inverted. You write. Okay. And see numerically M is greater than 1. So means minus 2 is also, forget about sign. Sign you have to say about real inverted only. That is means to say about nature. But 2, the number 2 is greater than 1. So you would say therefore the image is magnified or enlarged. You would say image is enlarged. So this is the way you have to solve the problems. Okay. So same thing, sign convection you have to apply. So always remember convex lens F is positive. Okay. For convex whether it is lens or mirror it is positive. Even R also. Even R means radius of curvature also. For concave F is negative. Whether it is lens or mirror, that you remember. Okay. Both R and F. Why? Because R is equal to 2F na. So that is the reason you can remember. If F is negative, automatically R will be negative, right? So that's it. So these you have to remember and write the points. Okay. When you are writing in exam, you have to write the points point wise like this. Means when you got V as 60, you have to write like image is formed at 60 centimeters. Okay, from optic center, like that you have to write. Okay. Okay, 60 centimeters from optic center means it is beyond 12. Means actually, if you imagine the situation, the object is kept between F and 12, but the image is formed beyond 12, real inverted and enlarged. So this is the thing. So this is one point. This is like first point number 1, and this is point number 2, and this is point number 3. Based on this, okay, image is enlarged. So this one. So these you should write. See, position for point number 1, nature point number 2. And size point number 3, like that. Okay, so in that way we can do it. Thank you. And you can pause and see.